Then I know the Hui she is the colleague from my Shanghai hospital. She worked in the research department. Then the Pei Zhen, yeah, Pei Zhen, can I hear you? Hello, Pei Zhen. Yeah, it seems like the Pei Zhen, her, yeah, I received the message from Pei Zhen. She said that she can hear me, but I cannot hear from Pei Zhen. But it's okay. But today, yeah, we will fix the microphone issue laterly because Pei Zhen, she is located in Taoyuan, so probably uh, she will join us remotely most of the time. But it's okay. I will test the microphone with Pei Zhen later on. Then Seng Kai, can you hear me?
老师，我听得到。
Okay, great. Because I didn't know your background. Can you 你可以介绍一下你自己的 background 吗？
OK，
In Chinese or in English is both okay.
OK， I majored in public health and statistics in university. So I work for the biomedical statistic analysis, just like the data analysis.
Okay, so yeah, I think we have a good company that Seng Kai, his major background is public health. So then Diana, can you introduce yourself a little bit?
And
Diana. No. I mean the Diana. Diana.
Yes.
Yeah. Can you introduce yourself a little bit?
My master is on health informatics, and I'm now in graduate institute of biomedical informatics.
Okay, so
I'm a lecturer from Indonesia, from Ministry of Health.
Okay. So do you know any our previous Annie ENNY Annie she is my PhD student. I think she is from Indonesia and work in the government. Do you heard about Annie before? ENNY.
I don't know exactly, but I will try to find the Annie.
Oh, okay. There's no problem. Yeah. So we got the Hui, Pei Zhen, Seng Kai already. Then I think there's Yan Jie. Yan Jie, are you online? Hello, Yan Jie. Okay. I think there's okay. Yeah, Yan Jie. Yeah, she has the yeah, I know her, so I introduced her to everyone. Yan Jie, she is a radiology technician. Is also from Shanghai Hospital. So I will test the microphone for with Yan Jie later on. Yeah. Then there's because I'm in the main campus. There's another Dr. Chen. Yeah. Introduce yourself.
Hello everyone, my name is Chen Junyou. I work in Wanfang Hospital and I'm a radiation oncologist. And I also work in our IT department to make some system for the clinical use.
Yeah, he is a good programmer. So if you are interested on programming, then you can ask him. Yeah, so I know, yeah, so right now we have radiologist, we have one ER doctor, then one public health, then some medical informatics. Okay, so we got a good combination of the work. So usually, probably I will divide all of you into two groups. yeah, but we don't need to decide it right now. So then we will decide the group later on. So it's okay, but we can discuss what kind of topic you are interested. Then I will first I will ask you to write a proposal. Then yeah, it's kind of I will teach you how to design the study. Then we in I think is maybe from the middle of this course, then we will do some hands-on class. So for that hands-on class, yeah, probably I will need you to go to the but some physical space that we can work together or that kind of thing. But yeah, don't worry about that. We will discuss on that. Then Jessica, she is my TA for this class. Then I think yesterday she already sent out you the information. Then I will create a line group for 2018 CDS class line group. So I will distribute the information through the line. So then we can get more easy conversation. Yeah, but usually the first day is kind of struggling. We will fix some technical issue. Then I think I will check with the Chu Hui, yeah, or the Kai, the Shen Kai. Yeah, I saw your video. Yeah, yeah, but I still cannot hear the Chu Hui, Pei Zhen, and the Yan Jie. Yeah, but yeah, I will find some time to fix the microphone. Yeah, but it's okay that we will find the Da'an campus. Then you can talk to me face to face. Then usually I'm flexible that if you cannot attend this class on time, so I will record it. I will record the class and put it on the cloud. So yeah, if you really cannot catch up the class time, that you can see the class material online. So it doesn't matter. Yeah, but just send me a note that let me know you cannot online. Then yeah, because today I cannot hear all of you. So usually I will ask what you are interested. Then we will decide it, what kind of research topic we can design. So the work after today's class is I will create a line group. Then I will ask you what kind of thing you are interested. Then we will design the research later on. Yeah. So this class it has many names, but the more formal name for this class is called a clinical decision support system. Yeah, sometimes we refer to CDSS. Okay, so that's mean clinical decision support. But actually, from the Professor Jack Lee, our previous dean, from his went back to his time. Actually, they call AI at that time. So actually, yeah, the artificial intelligence AI is the hardest the title in the medicine or all over the world. But actually, in the past, before we have the term called neural network or the clinical decision support. Actually, they call this field called artificial intelligence. What does that mean? Artificial intelligence. Um, that's implied that we can use computer to do something the medical expert can do. Okay, so yeah, that's the AI do. But why in this 2 year the artificial intelligence become popular again? That's all because the performance of the AI is outbid the professionalism. Yeah, in the past, the AI they only can reach 80 or 85% of the performance of expert. But right now, the AI can outbid the world champion, chase the gold player, and the Stanford, their image recognition system can outbid the clinical doctor. So the AI become the hottest issue, the topic again. So, but we don't go. I don't. Yeah, maybe later I will touch a little bit the AI and what's the most the advanced development of this field. But yeah, I just want to give you a formal idea about what does that mean. What is this? What is so-called the artificial intelligence or the clinical decision support? Then how to use it and how to evaluate it and how to improve it. Then I think that's the most important thing. Then the second thing is I want to tell you is about this class is a little bit like the statistics. Actually, the clinical decision support is just like it's based on the statistics. So yeah, we will talk about some probabilistic. So yeah, it's I will call it it's all non-process. All non is mean when you understand, then you fully understand. When you don't get it, then there is no okay, I got it. I'm 30% understand. So there's no way that yeah. So it that's mean that you will spend some time to digest the information, then get it. But yeah, so that's why I designed a hands-on lab that we will in some after you receive some introduction class, then I will teach you. We will do some hands-on job experience that you can get some idea about it. Okay. Then yeah, I forgot to tell all of you a little bit more my background. Yeah, my primary appointment is in the Shanghai hospital. I'm a neurosurgeon, so mostly I spend lots of time on doing the surgery in Shanghai hospital. Then personally, I like computers, so yeah, so I do coding. My PhD is based on the terminology like the ICD, knowing code, the thing. But my master, I spend lots of time on patient network. So I'm also have a strong base on the machine learning thing. So yeah, so this class, yeah, I hope you can have the idea what does it mean the clinical decision support. Then we will also cover some actually the clinical decision support is all about it's all tied into the development of medical informatics. So you will hear some concept here, then you will hear the similar thing from your medical information informatics introduction class. Okay. Okay, so let's start it. I yeah, like I say that everything I will upload to the website. Then don't worry about the PowerPoint. I will distribute it to you. Then you can go to the website. They got a hyperlink on the syllabus. Then if you want to join the video conference, I think yeah, my TA already teach you. Then there's a two textbook. I also put I also give you the link of the Dropbox. then you can download. One is a textbook written 2004 called Clinical Disease Support. All the author are some famous guy from the medical information. Some of people I knew them personally. Then another textbook is the data mining. Is a manual book for the WCAG. So it covers some good concept about if you are really interested about running the data mining program, then that is a good manual book. You can take a look at that. Okay, so this is some material you can get from the website. Then, yeah, for those recorded video, I will also put on the website. So, yeah, but anyway, we will create I will ask Jessica to create the line group. So yeah, I will distribute the similar information from the line through the line. And this about a little bit about me. I graduated in 2000. I'm from TMU. Then I got the biomedical informatics degree from University of Utah. So what you what you will learn is some material I learned back on the University of Utah. Yeah, here this is the campus. Then yeah, so talk about the goal of this class is we will talk about the history, and we will talk about the concept and origin. We will talk about some case study, and we will discuss how to generation and the formulation of knowledge, and about the standardization and knowledge management. Then yeah, here I want you to I want to tell you one thing is probably you will feel a little bit frustrated if you are new to our medical informatics program. Then you will feel there's a lot of English and a lot of terminology. Then I'm apologize that yeah, actually I can tell you a story that actually even when I was studying in Utah, then the first class, I remember first 1 or 2 months, then one of my American classmates told me that, yeah, I really had this class. Then I say, why? They say, oh, there are too many terminology. There are too many vocabulary. So yeah, but I think that's one of things you will learn from this class is because why we need to learn a lot of terms. That's because we need to communicate intelligently. So not for this class. I think for all of you, especially the introduction course of the medical informatics, that you will feel kind of frustrated about terminology because there are a lot of new terms. Then we keep repeat some different terms like interoperability, those things. But don't feel frustrated. It's a necessary process that you need to learn the scientific term, then you can communicate scientifically. So don't worry about it's just the beginning. So you will feel frustrated. There are a lot of terms, but anyway, I'm being student too before. So if something probably I guess you won't know, then I will explain you a little bit. Then it's welcome that you can interrupt me at any time that I will explain to you. Okay. Then this is the cover of the textbook called Clinical Disease Support, the raw and raw. Then it's a relative new textbook. It's written on 2004. So yeah, you should know that like the Utah PMI department, they got a history more than 40 years already. So it's the long development process. So I choose this textbook is because it's all is kind of summary about the development history in the past. And Robert Greene is kind of famous guy from the medical informatics. So we will use this class. And yeah, I think he is from the Harvard Medical School and the Brigham and Women Hospital. No, this is affiliate hospital of the Harvard Medical School. So yeah, I will follow the outline of this book. Yeah, first I will talk about the definition, scope, challenge. Then we will talk about some history. Then I will tell you some feature of the clinical decision support. How does it look like? Then we will use some real case. We will talk about the Regan strip system. Regan strip is the one of two first place they have the medical informatics system. So we will use the Regan strip medical informatics system as an example. Then also from the partner healthcare, the partner is a IT. It's a spin-off IT office from Harvard. Yeah. So when we talk about the partner, is imply the Brigham Women Hospital. Then we will also talk about the LDS hospital experience. Then I'm from Utah. The LDS hospital is from Utah, so I will have more thoroughly experience about the LDS. Then yeah, so then we will talk about the history. Then we will talk about the real implementation. Then I will also talk about some algorithm, the machine learning, the wake up. Yeah, we will not only give you some knowledge, then I will give you some idea about how to conduct the experiment. Then yeah, then get your hands some dirt, get your hands some dirty, then you can play with the data set. Okay, so that's probably the outline about the class. Then today I will give you some very yeah, I forget, this is a 2-hour class or 3-hour class. Anyone know?
This is a 3 hours class.
3-hour class. Okay.
Yeah.
Okay, but usually, yeah, it's a little bit late. Then you, it depends on, yeah. Usually, I will spend about around two hour, 1.5 hour and about two hour, to yeah. So let's see. Okay. But usually the class will end up before 8. Okay. Okay. So yeah, let's today we will talk about the history about the clinical decision support. So at the very beginning is the clinical decision support is start from 1960. At the beginning, I would say that is kind of a proof of concept era. Let me use the Utah as an example of why the Utah is some early program about the clinical decision support. If you know that actually Utah is famous for computer, I think everyone you use the PDF, the Adobe PDF file every day, then actually the Adobe, the founder of Adobe is graduate from Utah. So from our school, there are a couple of buildings is donated by Adobe. So back then in 1960, that in Utah, computer is kind of because there is no so much place they have the computer, and Utah is one of place they have computer. So the founder of the University of Utah PMI program, Homer Warner, at that time he is interested about computer. So back then he is thinking that why not I can input all the data from ICU into the main computer. So every day, then he can run some program. Then so then he printed out. He used some computer to organize his ICU patient uh, every day. Then this the problem of the patient. So that's a very early development of the medical information. It's all because in Utah we have patients and we also have computer. Then we have couple enthusiasm people. So so that's the at the very beginning. We have patient, then we have computer. So we are trying to put some data, patient data into computer. But you should know that only after 2000, I think, I remember, before 2000, that in the clinical field, they are very conservative. If you do some data mining or you do some computer, some very fancy algorithm, you have some idea find from some your database, then actually the clinical journal they don't like it, so they think the computer just a tool, a toy. So the clinical journal they don't accept the paper based on the computer method. So that's the very beginning. I think before 2000 years, it's all have similar uh, situation. So at the very beginning is kind of yeah, from 60 to 85 is kind of some hobby for those enthusiasm for computer. Then since 1985 and to 1988, they start to apply the computer into clinical workflow. I still remember the dean, the Professor Jack Lee, he back to Taiwan in 1994. And 1994 is, I think just, officially we say 1992, we invented the internet. Then, I remember in 1994, the TMU, Taipei Medical University, we create our first computer center. Then I think it's around 1998 that we got the all the data. I mean, we integrate the computer into hospital. So yeah, so it's around 1985 to 1988 that we deploy the computer into our clinical work. So at that time is we think computer is kind of helpful. So yeah, we start to transform the paper-based system into computer. So I think the critical point is since 1998 to 2003, because previously we talk about this clinical decision support, but everything is on paper based. So the problem is everything is on paper based. So that does it mean that it require the extra effort that to input the data. So before that, everything is not digitized. So it's not very easily to implement the clinical decision support. But since the 1998 to 2003, that we talk about a lot of possibility. So here they talk about you see the safety and the quality. So actually in 2002, there's a slogan from EMEA. They call patient safety. I forget is who. I think it's David Bates, one of author from this book. They talk about uh, they they uh, try to advocate the importance of the patient safety. So in the 2003, I think the most uh, significant example is the drug-drug interaction. If you know that we know in clinically there are some drug is when they put together with some other drug, they will create a disaster interaction. So we have different classification for the drug-drug interaction. So I think, yeah, you can imagine in that time, back then, it started to use the computer to prescribe drug. You use computers to prescribe the drug. Then they are the first time they can use a computer to analyze the drug-drug interaction simultaneously. So yeah, people feel excited. But for you, right now the drug-drug interaction is kind of trivial thing. But back then, we just started to use computer to prescribe drug. Then yeah, they're still very exciting at that time. But since 2004, because everything is in computer, then we are think about what is the future of the medical informatics. Then we start to talk about the EHR, electronic health record. How does it should look like, and the CPOE? Yeah. Here you will hate it. Why there's a lot of term. CPOE in Chinese is 门诊系统. CPOE is mean the 门诊 system. It mean when you seeing the patient in OPD, then you will use the system we call computer-based provider order entry. Yeah, you should familiar with this term, the CPOE. Then the electronic prescribing, then the personal health record. Yeah, the EMR, EHR, PHR. Yeah, they are all similar things. Just they have slightly different on the scope. Then after 2004, then everything is in computer. Then we have lots of, we also have the standardized EHR. So we start to think about, can we reuse the knowledge? Okay, so when we talk about the reuse of the knowledge, then it become, yeah, we will talk about the standardized, then we will think about the expandable feature. So, but yeah, so right now you will see that at the very beginning, it's just a proof of concept about can we apply computer in clinical setting. Then we start to utilize it. Then we talk about the EHR, the integration. But I think in the future, I think right now we are in 2018. But I guess the update textbook, we will have a new milestone is in 2016. I think it's the AlphaGo outbid the human being. So there was a hallmark say the CDS outbid human being. So yeah, that's I'm guessing. Yeah, so we all live in the history, but we look back in the future. Okay, so here is the history about the CDS and our current status. Then, yeah, we all know the AI in medicine. The the new thing, this not from textbook. We will cover it a little bit.
应该不会有问题了吧？
Yeah, yeah. 谁有问题？Hello，Hello，刚刚谁有问题？Okay, so probably I think it's from Jessica, but I guess she is talking to some other. Yeah, okay. Yeah, we will cover a little bit about. We will cover a little bit the AI in AI in medicine. Then here is the component of clinical decision support. So there are some terminology. We will talk about the decision model, the knowledge-based information model, and the result specification and application guide. So here is some module that we will talk about. Yeah. So you will see here, here's come a cartoon illustration about the clinical workflow in the CDS. You will see in clinical, this I think the knowledge measure and dissemination here, or the clinical knowledge here. Then we will implement the CDS, but then we will evaluate the performance of CDS. Then we will do some validation. Then here is kind of interact cycle. So you will see the knowledge is circulating between different process. Okay, then so here is some methodology we will use the clinical decision support. Because clinical decision support is kind of broad term. That can imply that all the system or the IT or the technology used in clinical setting, then we all say it is a clinical decision support system. So I think the first term you will learn is the so-called the information retrieval. I think the best the best explanation about the information retrieval, I think, is the Google. I think the daily. I remember the one of first book I read for machine learning. This called information retrieval. Yeah, it's kind of amazing that actually on daily basis we in the hospital we are using the information retrieval, and that the major use of the information retrieval is we are trying to finding information and answering questions. So currently there are lots of there are lots of improvement about the information retrieval is going on. Yeah, like the Jin, he developed a IT system, the lazy R. He improved the GUI and the search interface. Then you can easily find in the information and answering questions. So the key development that we'll talk about the taxonomy, ontology, and the text-based method. Here I want to explain a little bit about the term ontology. Ontology, I think this you will hear it again and again about ontology. Ontology is about talking about a vocabulary, and but they not only define the ontology, they also define the relationship between the term. For example, if we we say the vehicle or car, okay, the Porsche, the Mercedes-Benz, the vehicle or car is the more is a more general concept about of car. Then down to the car, there are different brands. We have Mercedes, Porsche, Ferrari, Volkswagen, whatever. So, so we will use ontology to define those relationship. Is all these cars brand is all belong to vehicle, or you can call it cars. So that's mean what's that important? If you all use the PubMed before that, sometimes they will ask you, do you want to expand your search or not? Then that's the powerful of ontology, because when I will use this as an example. So when you search the internet, when you search the keyword Mercedes-Benz, then I will know if because the Google, they have the ontology. So when you search the Mercedes-Benz, then they know you are searching the vehicle information. Then they will also know it is a luxury car. So through the help of ontology, they will know you search the Mercedes-Benz, it's searching the vehicle and the luxury car. So they can probably also give you the similar information. For example, they can demonstrate the Lexus information or the BMW information. So that is the powerful of ontology. One of the powerful example of ontology that can help you to do the information retrieval. Okay, so yeah, the Google or the daily software we use in the database system, we utilize the information retrieval. Then actually, this also could be a possible research question is because like the Professor Jack Lee previously, he has a learning health hospital system. Actually, one of his first goal is try to create a search engine for the ICD searching. So yeah, so if you are interested about developing a good information retrieval engine that like for example the cancer registry or whatever, it could be a master, I won't say PhD, but I will say it's qualified or a master program. So that's the information retrieval. Yeah, we in hospital daily, every day, we are search the information. So then the second thing is, I think the second is more important is this is the couple thing we very important we use right now daily, that we call alert or reminder and constraint and inferencing system. So I think, yeah, is anyone can answer about what's the difference between alert and the reminders? Anyone can answer?
Alert is something like a warning, but reminders is the system give the information to remind someone.
Okay, yeah, that's it is yeah, I think yeah, it's correct answer. Yeah, alert is means something you should watch out, and probably something bad that you should be alert. And reminder is something that you should know, that just for example tell you some people they will have operation tomorrow or whatever. Yeah. easy understand from the alert and reminder. And actually, reminder, you know, one of my classmates, I know one of my classmates from uh, Utah that they just develop a reminder, then it's become a PhD thesis process. Yeah, because they develop a system called info button. If you are interested, but actually personally, I really don't think that's very innovative. Actually, they just design an info button. That means they will put the button on the EHR system. So everything, if you are interested, then you can click the button, and they will display the information for you. Yeah, I think it's straightforward, but it is true that uh, I know one. Uh, I think right now he is a assistant professor or something. They just created this kind of system. It become a PhD. But again, but sure, they develop a standardized based on it. So yeah. So you can see that you can see the major use here. The alert, reminder, constraint, inferences. This is all based on the evaluation of logical condition. So I think you got the idea that is, I think the how do you create the alert? How do you create the reminder? How do you create some constraint? It does mean you will have a set of logic. Then when you do something, then they will try to check it. So yeah, so based on this, you can you can how to achieve this is you can create a decision table, then you can create an event condition action rule and the production rule. So in here, sometimes we call this called rule-based system. Rule-based system, that means yeah, the decision is kind of straightforward. So I just need to write a rule, then it's fulfill the rule, then I will create an alert or reminder. Then that's some just like a computer logic. We just execute, I mean, just evaluate the logic condition. Then the third thing, the probabilistic data-driven classification of this is more complicated. I won't go into detail about this because this will we need to spend one whole class to explain this, but that is the key main thing from this class. So I will spend a whole class to explain what does that mean, the Bayes theory, the decision theory, what is it, ROC analysis. Yeah, remember the ROC, not Republic of China, but ROC, I think the Jack Lee, I think is a quiz question. I think every year, I remember every year they will ask you how to, please use some example to explain the ROC curve, okay? Yeah, we will talk about the logistic regression, artificial network, and the belief net and meta-analysis. Yeah, but yeah, just that you know, yeah, probabilistic. I think this is the heart of the clinical decision support system. Then there are some heuristic modeling and expert system. The heuristic is mean. I think for you probably some new, but heuristic is mean experience-based learning. Is heuristic is mean if one doctor they seen patient many years, then they will have some experience. So based on the experience, in that case we call the heuristic modeling. That means it's based on the previous example learning. So then you can also do some calculation, the algorithm. For example, you can calculate some or Charles score, and clinically we have a lot of flow chart like the triage from the ER. Yeah, we can do some calculation. Then the associate group element. This a little bit like the data mining. Later, I will use the whole class to teach you about what does mean the supervised learning and the unsupervised learning. But just give you a test about that we have different kind of way to learn the knowledge from the data. So here's the outline. But just this for all of this, some of this I will use a whole class to explain this. So stay tuned. Okay, so yeah, here is the example I show you. You see this is I, here this is a button. Yeah, this is called info button. Yeah, you can see the info button. I think it's developed by, yeah, I forgot the name, but yeah, I know this guy, yeah. But you can see that, but back then, the 2000 is kind of a very charming thing that in the past, I think back then they still, I think 2001, they have Google or not. I think Google is from 1998. Yeah, so yeah, they just put a button there, so you can easily to get some extra information from the system. So it's kind of, yeah, in this case we call it the reminder. So yeah, you can see, yeah, here, but you can use the automatic or semi-automatic retrieve because you can do a real-time search on the internet, or you can manually curate the database to display that information here. So yeah, if you are interested about doing this kind of thing, yeah, it's still okay. Yeah, but just you need to think about what's your creativity part. Then this is difficult. Yeah, you can see, but this just want to show you the difficulty about the how to diagnose this disease. You can see all the doctor. You can see one patient, they probably can have arthritis, chorea, and carditis, all this mixed together, but they will have some overlap. But usually, this graph is in their brain, but we are trying to reproduce this in the computer algorithm. Then we will try to represent this kind of relationship in algorithm. So in this case, we call the probabilistic. Okay, yeah, oh yeah, I forgot the name. This is the spectrum of rheumatic fever. Okay, so yeah, if clinically, if people they have rheumatic fever, they will have arthritis, carditis, chorea, and this thing. So, but clinically, they will have different overlap shadowing of the data. Then this is the a representation of the clinical cancer. They can have a primary, systematic, metastatic, and asymptomatic of cancer. So they can draw a Venn diagram to this. So here you need to learn this kind of graph we call Venn diagram. Okay, this is hard. Then just give you an idea about the Bayesian network. How does it look like? This I spent honestly. I spent 1 year to get understand about this. This is not very easy, but I can give you an example about how to do this. I always use the example that, for example, if you sit in the if you are here with me in this classroom, then there are somebody knocking the door. Then I will ask you to guess, is this a boy or a girl? Then you don't have any information. You didn't hear the voice. Then you only can just guess in that maybe 50% is girl and 50% is boy. But if we change the setting that this is in the hospital, then I will guess probably it will be a it will be a girl, because in hospital mostly there are a lot of, yeah, the number of nurse is way more than the number of doctors. So just naturally the distribution is a little bit different about the nurse and the doctor. So I will guess the 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 chance of girl will be higher. But if I give you more information that that's the person who knocked the door, it's kind of long hair, then you will probably feel more confidence that it will be a girl, because the nature, if you see the people with long hair, usually it's about it's talking about a girl. So yeah, so that's the what this is what's so-called the Bayesian theory. It's based on give you some condition, then you will guess the given a condition, then you will guess the the probabilistic about certain circumstances. So this is very likely the diagnosis behavior about disease. So if patient they come to the OPD, then we will ask them, oh, do you have fever? Then okay, but I think the fever is not very sensitivity. Sorry, not very specific to any kind of disease. Then if patients say, oh, I got a skin rash on my body, then they will guess that probably kind of like the rose dermatitis, that kind of thing. Okay, so this is so-called the Bayesian theory, that they will give you some observation. Then after the observation, then you will guess in some probabilistic about some other condition. But yeah, this I tell you, this is difficult. I draw this on my paper and try to figure it out and try to internalize this idea. But honestly, I spent 1 year to get the idea of this. But don't feel frustrated. Later in the following class, I will use a real example, then ask you to do some calculation, then you will have more feeling about this. But I just give you a sense about, we will talk about the probabilistic later on. Then this is the decision tree. I think you look at this. Clinically, we use decision tree more because the decision tree is more human readable and is more coincide with humans experiment. So so in your case, if you see some illustration like this, you will know this is called decision tree. Then in the future, the week1, the machine learning algorithm, they also can apply the decision tree. So it's very powerful. Then you can draw a graph. So then, yeah, we can use decision tree to help us to do the prediction of disease. yeah, this the patient network. This more complicated thing. Yeah, no, you can use a lot of node to create a causal network. Yeah, but this yeah, again, we will spend another class to explain this. And this is some flow chart. Yeah, some dialogue. I think the Wan Xiaofang is more like this. They have a flow. They ask you some question, then they will define some flow chart. But actually, the amazing thing is this possible that you can create this kind of flow chart from some big data? So that would be very useful. That yeah. So how do you can you create this kind of flow chart automatically? Okay. So yeah, I don't want to go too much detail about this. Yeah, they just yeah, we will cover those things later. So this is the a concept model about the clinical decision support in happening in hospital. Uh, Usually you can see that this is the application in mind. That means the HIT, the health information system. You can see the EHR is here. Here is our EHR here. Then we use the, like for example, the web-based or the standalone program the user can operate it. Then here is because from the left hand side this graph is the user they execute the daily program. So usually we don't want to interrupt our daily practice. So usually we will use this kind of interface to send out those event into some other module. Yeah, so actually the fire, if you hear the fire or the smart EHR, they describe this thing from the web container because they try to develop a clinical decision support system based on the web container. So yeah, usually you need to draw this kind of thing to isolate thing. Then you define the event, the whole thing. Then yeah, so you can follow those thing to implement it. So yeah, Regan strip. You can back then. I think this is around 1960. They use. I think this some tape base. They use at that time. They used the tape to store the data. So yeah, so they use a very bulky machine. Then yeah, we all know that 1960. I think before the computer. Yeah, personally, I'm kind of a history person. Yeah, I also use some paper-based chart also. Yeah. So based on that, so after we move on from digitized version, then we can start to have this kind of, I think, web-based system. So you can click, you can do some prescription. Then yeah, yeah. When you do the medication, then they will give you some warning that sulfametolide. Uh, they give you a warning that you double dose. Then they will give you a reminder. But so for example, this is a very hazard. Oh, sorry, I say the keyword to wake up the Siri. Then so if you don't answer those questions, they will give you the constraint that they won't allow you to continue the order. So this is the powerful that everything is computer based. So you can do some rule based check here. So yeah, so that's powerful. But for us, yeah, this is already in our daily life. So, but back to the early stage, this kind of thing is kind of very charming thing. So this is another illustration. You will see it oftenly is because it's from the help. Help is a IT system from LDS, the University of the Intermountain Health System. So actually, they create the electronic health record here. Then they integrate all the different kind of modules. So they have center here. So they got the medical device, they got the laboratory, financial, some administrative information here. So they put the knowledge here, decision support system, then create the alert suggestion. But you can see the EHR is the heart of all the health information system. So they just use the data driver and send out the information to here. Then the time driver, it doesn't mean the data driver is mean it was driven by data. Then time driver is mean they will check the rule on regular basis. For example, they want to remind some people they will have operation tomorrow. It's not necessary you check this every 5 minutes. So they will use time driver that maybe every 6 hours they create a reminder, this kind of thing. So this is a whole picture about the health information system from health. But anyway, I say we will introduce the LDS Intermountain system. So later on, you probably will see this again. So yeah, I think we already see this, the patient data here, suppose doing support engine here, other file. So this some breakdown about the system. Okay, so I think this similar thing. They just show you how the expert and how they interact with physical user. This about the logistic regression. How can I think you see this before? Clinically, we check the lab about TSH and the T4 to try to diagnose the thyroid disease. So you can use the equation to calculate this. Then you can create a more complicated form that the TSH and the T4, and they will all come. Anyone can see the difference between the A and the B. Yeah, if you can see or can explain the meaning, then yeah, you become a expert about the CNN. Then you can web this class. Anyone can, I mean, here is a TSH here and T4 here, and the TSH here, T4 here, and they create another layer. Can anybody can say this different? I think this a little bit like the multivariable. We have logistic regression, but we also have the multivariable model logistic regression. Okay, yeah, it's good that I can teach you something that the difference between the illustration A and the B is in the TS here is they only care about the TSH and T4 independently, so they don't concern about the each other. But in this case is they create a layer that, for example, the state W2, the TSH all contribute to this node, and the T4 also contribute this node. That means that the thyroid disease is not only diagnosed by TSH solely or T4 solely. They need to consider both of these at the same time. Okay, so so if we use another way to say this is the TSH and the T4, they have some interaction. So we need to create this kind of middle layer then to do it. Then actually I think recently the deep learning is kind of hottest trend. Actually, this is kind of a CNN graph. You can call this layer for convoluted neural network. Okay, they just create another middle layer to do this. Okay, but yeah, the CNN is more complicated. But actually, they have a different. Usually, they have 256 layer. They have a lot of layer to do the neural network. But I think I promise you that we will explain a little bit artificial learning a little bit. So yeah, later I will use a real example to you. But just remember, it's kind of when we need to consider the state of TSH and T4, we will use this kind of middle layer to illustrate that kind of relationship. Okay, this is another graph about the classification tree to this. Okay, so you can see this is a decision tree. Then if we use the graph to see this, then actually you can, yeah. So this, what does that mean? This means when your condition or your circumstances is not too complicated, then it's more the straightforward. You can just use one thing to divide, or sometimes we say it's a linear distribution. Then we can use this kind of method to classify it. Yeah, classification again. This is a new term. In the future, I will explain it a little bit more. Then this is a more complicated example about the decision tree. Then, but yeah, compared to this, yeah, this, yeah, I think I missed, yeah, this is the binary distribution. Then actually, I want to let me back to. I want to show you another thing is the SVM. So, okay, here is some other example. So if something is more complicated distribution, then we will utilize more angle or vector to separate them. So in other terms, it's not binary distribution. So we will use a more complicated plane to separate it. So yeah, like this, then I think, yeah, or like this multi-dimensional. So yeah, so the support vector, yeah, so I mean, in nature environment that everything, it's very few that thing are binary distribution. mostly their distribution is like this. So yeah, the support vector machine or the CNN, they all are invented to solve this kind of a problem. So yeah, so that you will see that because we are handling a more complicated data set, so we will need to utilize a more deep, complicated algorithm to represent the data. So yeah, but again, this is the introduction. Just give you some idea about the history, about the development of CDS. Then later, today I will also show you some different methodology about the classification, or sometimes we say prediction model. Then we also explain some application like alert, reminder, and so on. So the following class, we will talk about, we will use some several hospital or institution to give you the real example. Then we'll also introduce some methodology. We will talk mainly, we will introduce about the supervised learning and the unsupervised learning. Then after you got the concept about continuous decision support, then I will divide all of you into two groups, and we will work on a small project. Then yeah, we will see what you will learn. Then because you will go through the whole process, then yeah. Okay, so yeah, it's probably all the material I prepared for today's class. So anyone have some, yeah, is there any, I see some people they can use microphone. So I see the Ting Hui. Hello? I saw the name Lin Ting Hui. Lin Hui Ting, sorry. Lin Hui Ting. Or Yan Jie, still there? Hello, Yan Jie. Hello, Yan Jie. Hello，燕姐有在吗？And 盛凯还在吗？盛凯
老师我在。
在哈。那你们那个画面看得清楚吗？
清楚。
我这边也很清楚。
清楚哈。好 ，OK。那个关于今天的课程有没有什么问题？
老师我这边没有。
刚刚有人在说话吗？那佩珍，你那边有没有什么问题？
目前没有。
那个我有请之前那个林国轩，他之前有做过那个基本的 triage 的部分，我会邀请他来帮我们讲一堂课，分享一下他在做 ER 的那个 triage 的 project。Yeah, one of our previous student who is working on a ER triage program. So I think yeah. One thing why I asked him is I remember we prepared the data set for couple of studies. So I'm thinking of one of example is we will utilize that data set. So you can see how we use the data from national insurance database, and also include the triage information to do some I think I remember we are doing the mortality prediction for the 30 days. Yeah. Okay, so is anyone the 秋慧 still there？秋慧在吗？你的麦克风可以讲吗？有哈。OK，有 OK，好。Okay, so I think that's probably the all for today. Then I will ask my TA Jessica. I will include all of you into a line group so we can more easily to connect to each other. Then I think I will find a physical space located in Dine campus. Then I will go to the Dine campus. So if you are nearby the Dine campus, you can just come to the Dine campus. But again, some of you just due to the clinical work or whatever, if you cannot physically be there, then I'm welcome you just attend the meeting through the video conference. And, okay, so yeah, I think we get everything online, then yeah, give you some idea and think about the idea, what you are interested. Then yeah, we will talk about more next time. Okay, so probably that's all for today. Then I think I will post all the material on the website. Okay, then yeah, we will keep communicate through the line. Okay. Okay. So I will finish the today class.
OK，谢谢老师。
Okay, bye bye.